everyone. In this recording, I'm going over Lab 3.4 in the second data analytic project, which is a time series prediction for the IBM sales and earnings data. For forecasting or predictive analysis, we majorly have three different tools. One is the time series we are doing here. For predicting use time series, you are looking for the past trend, like we have the historical data related to the different time periods. So we use the past trend and how we are going to predict the trend will continue in the future. So the prediction is pretty much based upon the fluctuation of the variables over time. And the other one is use regression models to make predictions, like single variable models or multi-variable regressions, like the one we did in Lab 3.3. So you use the past data, so you are not only looking for the time. Time might be one factor, but we are looking for how the dependent variable will change depending on the independent variables. So you construct a regression model based upon the past data, and then use this model to make prediction in the future. So we call regression predictive. And the other one is classification analysis. So classification is normally for categorical data. So for example, if you are a bank loan officer, when you receive an application of business loans or application of credit card, right? So they need to all review the profile from the applicants, and then based upon their, past credit history, income levels, education, and group of variables, so they can decide should they accept this application or not. So classifications, you base upon the current existing or the past like customer profile and try to analyze how likely this new applicants, like should I accept it or rejected. So classification. So time series prediction, regression prediction, and classifications. And this one is another time series prediction. It's pretty much similar to the one the third question in the first project. So we are going to predict both for the sales and the earnings, but separately. Okay, you couldn't do both in one analysis. So I'm going to do the sales first, so you also can follow the instruction in the book. For predicting the sales, I need to put my mouse in one of the numbers under the sales column, or like one of the numbers will be fine. And then we are going to click on data and add the, let's see, the predictions here. Forecasting, okay, forecasting sheet. And they already give you a preview of the dialogue. Okay, so you can refine your options, and you can see it's automatically give you 3 years, because right now the data we have is until the end of 2021. So they are predicting for next 3 years, and you can adjust the forecasting period. Okay, I think probably you couldn't make it longer, but you can short it. And then you have some other options like refinement. Okay, how you want the change, update the confidence level. I think 95 is already very high, but you can adjust it down, because as you see, if I decrease my confidence level, so you can see the range of the upper and the lower of the prediction will be increased, because you are going to tolerate more variations, like the accuracy of the prediction. Okay, so you can adjust it here. And then I'm going back to the 95 is kind of a normal or popular confidence level choices. And you also ask the tool detect the seasonality. Okay, seasonality is normally like, for example, something related to the summer season or winter, maybe some like the electricity cost, energy cost. Okay, so that's like automatically detect. And I think in the book they ask you to include the forecast statistics so we can evaluate the fitness of the model. I think that's it. And but you also can, this is the data range. Or if you want to, for example, I want to only use part of the data. Okay, not all of the years. I want to just use partial data range, and you can adjust from here. And then you can click on create, and we'll see this forecasting graph plus the statistics related to the model. Alpha, beta, gamma. Okay, that's something related to the model fitness. And root mean square. And this is also, so the larger this one means the fit didn't do well. Okay, the larger the standard deviation means the forecast, they're less, so it's less accurate. Okay, because you have more errors involved in the prediction. Okay. So this is the first one, the time series prediction for the sales revenue. Okay, because you can see this zigzag, and that makes sense, right? Because overall, if you can fit a line, like for example, if I can fit the trend is downward, right? So that's what you can see. The prediction is pretty much going down continuously, but they did give you some variation of the upper or lower bound of the predictions. Okay, this is this one. Then, so let's see the second. Okay, because it's coming to a new sheet. Okay, so I'm going back to my original data, and this time I'm moving to the income before extraordinary items. Why we don't use the net income? Because extraordinary items are really irregular, or it only happens very rarely. So it's not your continuous income. So if we include extraordinary items, the accuracy of the prediction will be reduced. So I will use more persistent earnings, so consistency is enhanced. So again, put your mouse here and then click on data. So forecast. Okay, you can see this is more zigzagged. And also the option, I'm going to include the statistics, and then so click on to create. Oh, I forgot to include the statistic. Okay, you can add it. I think that's for the refinement. Okay, of the chart, the graph, the itself. But I can adjust. So for example, okay, if I do one more time, I want to include here. Okay, include the forecasting statistics. And this one. If you move to the right, okay, so it's over here, okay, the statistic. And you can see directly the root mean square of this one is lower than the sales forecasting. Okay, so you can use it to make assessment about the the relevance and how confident, okay, for the predictions. And because you can see this one, the zigzag is more wide than the sales. Okay, so you can see the upper and the lower boundary of the forecasting is also wider, so wider than the sales prediction. Okay, because if you want to simulate a line, even we do here, but you can see the root mean can give you this idea. Okay, like this deviation from the forecasting. Okay. So time series forecasting. And you can also check in the instruction. There are more discussion questions and thinking. Okay, use what you're understanding to answer those questions in from the Connect.